Hello arithmetic friends, today we're gonna study another case of percents. That's very interesting because in our real life we're using percentages all days, almost all days. So let's see one example about how to calculate an inverse proportional distribution. Maybe you didn't understand very well, but we're gonna see one example. The boss of a company wants to distribute a 225 euros punctuality bonus among his employees. The first one has 3 delays this month, the second one 4 delays, and the third one 6 delays. How much money from the bonus must each get? Well, first of all, we have to remember that all percent problems can be solved using the rule of 3. So, first of all, we're gonna write the delays of the 3 employees. The first one, the second one, and the third one. The first one has 3 delays this month. So, we have to see one thing. If someone has less delays, he must receive more money. But if he has more delays, he has to receive less money. That's why we are calculating an inverse proportional distribution. Here we have one trick. If the first one has 3 delays, we're going to write 1 over 3. If the second one has 4 delays, we're going to write 1 over 4. Because it is an inverse proportional distribution. Inverse. We are flipping the numbers. And the third one, 6 delays. 1 over 6. If you saw the last video, you understood that we have to add the data. If you want to know how to add fractions, you can see my video about addition of fractions. Here I'm gonna do it very fast. And simplifying the fraction, we have here 3 over 4. The delays are in this column, and here we're gonna know the percentages. 3 over 4 is gonna be 100%. But we need to know each employee what percentage of the money is going to receive. So we can see that here we have already a rule of 3. So we remember that a rule of 3 is made multiplying the numbers that have a couple in diagonal, and the answer is going to be divided by the number that doesn't have a couple in diagonal. Then we are going to write x is equal to 1 over 6 times 100 over 3/4. And the answer is 22.22%. Then I write that the third employee is gonna receive the 22.22% of the money. After that, we forget a little bit the third employee, and we are gonna consider the second employee with the total. Here we have another rule of 3. 1/4 multiplied by 100 and divided by 3 over 4. So we write 1/4 times 100 divided by 3/4. And the answer is 33.33%. We're going to write it here, 33.33% for the second employee with 4 delays. And the last answer is going to be calculated with the total and the first line, the first employee. So we have another rule of 3. 1/3 times 100 divided by 3/4. Then I write x is equal to 1/3 times 100 divided by 3/4. And the answer is the 44.44%. For the first employee, you have the 44.44% of the money. How do I know that I am doing it well? If you add those percentages, you have to get 100%, or almost 100, 99.99%, because of the roundings of decimals. So, to know how much money is going to receive each employee, you have, as we've seen in the last video about direct proportional distribution, you have to write the percent in a decimal form. You move the decimal point 2 places to the left, and that's it. And you multiply that percent times the bonus, the 225 euros that you want to share. After that, the same thing, 0.3333 times 225, and after that 0.2222 times 225. But be careful, if you want to get numbers that are right, you must take all decimals in your calculator. So we are going to use 0.444444, all numbers you can, and you are going to multiply that quantity by 225. The answer is, if we round the answer, 100 euros. After that, if you consider all threes in your calculator, the answer is 75 euros. And finally, the answer for the third employee is 50 euros. How can I know that everything is okay? Well, we add those numbers and we get 225. That is the money we want to distribute between those employees. And it is logic. If one employee had 6 delays, he receives less money. And if one employee had only 3 delays, he receives more money. That's why this subject is called inverse proportional distribution. Thank you very much for your attention. Please subscribe to our channel and see the next videos about more subjects, learning math like no one in this world. Thank you very much, dear friends. See you next time.